All right, attendance. Let's go here. We got, okay, Olivia's still gone. Garen, I don't see Garen. Right? Okay. And then Jocelyn, I don't see. Levi's here. Mario, I'm missing. I'm missing somebody there, or is it just somebody who left your cover? Okay. That's right. Yep. Okay. And then I'm missing Sinai and no. Okay. A lot of people gone today. Wow. Okay. So, all right. Let's see. Okay. So today we're going to start in, I'm sorry, Carson. I got to take care of that for you. I'm so sorry. There's so many logistical things that I have to keep straight in my old brain. Okay, Carson W. So you've got 8.2 and 8.3 done?
Yep, and then I sent 2.8.
Okay, perfect. Okay, I got that updated then. Okay, so we're going to spend some time going over how to write formulas again, because I think that's kind of a weaker spot, and we're getting ready to go into balancing equations. So we're getting ready to go into stuff like this, where we give you two things, and I'll teach you how to do the rest of this, where you got to figure out what it's going to make and everything. But if you don't know how to write down some of this stuff to begin with, you're never going to get those equations to come out right. So I want to backtrack, and I want to spend a little bit of time today just making sure that you guys are firmed up on how to write these formulas, okay? So we're going to go through this. You were gone to, I gave out a packet last week. Mine's still gone. Carson's here. That's your packet. That's what we're going to start in. That's got your homework in it for tonight. He's gone. Melanie is here now. Okay. And then Olivia. You grab that for me for just a second. No, that's the last one. I guess I don't need it. Okay, sorry. Thank you. All right, there's what you need. All right, and you didn't miss it, but I gave it out in case you got quarantined, then you'd have it. We've got so many people getting quarantined now that, or they're out with it or something, you know, it's just hard to. So I try to, when I get stuff printed out, I try to give it to you right away. So you need your periodic table out. You've got to have that out today. So we can start going through some of this stuff together, okay? All right, so let's get started here. When you are working with these, okay, if you see a metal listed, now how do we know that it's a metal? Remember, we've got that stair-step line on our periodic table. So anything that's on this side of that stair-step line is a metal. Anything over here is a non-metal. So if you see that this starts with a metal, that means that you're going to go by these ionic compound rules for writing the formula. And when you have that, you need to start by writing down, oops, I'm going to go over to draw here. You have to start by writing down the metal. You're going to write down the oxidation number for the metal. Now, that oxidation number is going to be found one of two places. Either in the problem itself, where they've given it to us here. So they've told us that this is a +3, or you're going to find it on your periodic table. So your periodic table has these little numbers here. Those are called your oxidation numbers. And if you come in and take AP Chem with me, I'll explain to you what oxidation is, okay? But for right now, you just need to know that they're oxidation numbers, or sometimes we'll call them charges. That's the other thing we'll call them. So if it only has one option, then we don't write it in parentheses. Like potassium only has one option. Potassium only has a +1 option. Then you go on to your nonmetal. Your nonmetal, you're going to look at the ending. If it ends in "ite" or "ate," you're going to flip over to the back side. So this is "ite," this is sulfite. Well, on your back side of your periodic table, you don't see sulfite, but you do see sulfate. Sulfate is SO4 - 2. Okay? We don't need sulfate. This is sulfate. We need sulfite. So, sulfite, you're going to take 1 oxygen away. And they talk to you about that. There's little rules up in the corner on there that tell you about how you, if you go down to "ite," the ending "ite" means 1 less. So sulfite is going to be SO3 with a -2 charge. So that's SO3 - 2. Now, I need to be at a 0 charge. So that means that I need 2 of these for every 3 of these. But I need to put this guy, because it's got to apply to the whole thing, I got to put all of him in parentheses before I write that 3 down. So now if I look at my charge, I have a +6 on this side because 3 times 2 is 6. And over here I have a -6, which takes me to a 0 charge. Good? That makes sense how I did that? You guys aren't going to talk to me? All right, this one ends in "ide." That means that it's not going to have, we're not going to have to go to our polyatomic list. This is just oxygen. Now, did he tell you about the oxidation numbers for the nonmetals? Did he go through that with you? Huh? No. Okay. Let me go over here. Go to this thing. Go here. All right. So I'm going to draw a little periodic table on here. Okay. Your nonmetals, you've got your noble gases here. Okay. They start with helium. We're not going to worry about them. Okay. The next one over starts with fluorine. So for fluorine, for chlorine, for bromine, for iodine, and for AT. Go through every one of those, and any number that's in here, the little numbers that are off to the side, anything other than -1, get rid of it. So everything in this column should have a little number over here, and that number should only be -1. All right, so for the next one, for oxygen down to TE, all of those should be -2 for that little number off to the side here. So -2, -2, -2, -2. Leave this guy alone because he's actually a metal. Bismuth is a metal, so we're not going to mess with him. We're just talking about the nonmetals right now. All right, next column. Guess what it's going to be? You seeing a trend? It's going to be a -3. This is your nitrogen, your phosphorus, and your arsenic. So all of those should be -3. And then your carbon and your silicon, those should be -4s. Okay, so get rid of any of the other numbers in there that are charges. Get rid of any of the charges from there. Okay, fair enough? Everybody cool with that? Oh, you guys are such a talkative bunch. It's hard to keep you under control. I go for my AP class where Mr. Ward actually has to come over some days and say, it's so noisy over here. Okay, so you guys, just like, he didn't get you to talk to me. All right, so the next one was that potassium oxide. So this is K. You should be able to find the charge of +1 for K, yes? Okay. Then your oxygen, now that you've got your new chart here, the only option for oxygen is a -2. So I need to be at 0 charge. How many +1s do I need to balance this guy out? 2. All right, so then this side would be a +2 and this side would be a -2, and we're at 0 and we're good. So that's the formula. Then chromium sulfate. Okay, chromium is Cr, and they told us in parentheses, they said Vi. What Roman numeral is that? 6. So this is a +6. And then sulfate, it ends in ATE. So that's going to be the back side of the periodic table. That is SO4, and it carries a -2 charge. And you should be able to find that guy on there without having to do any manipulation at all with him. All right, I need to be at 0 charge. How many of these do I need to get to 0 charge? 3, because I've got a +6 here, and 2 times 3 is 6. So, but it has to apply to the whole thing. So I've got to put it in parentheses so that that -2 will apply to the entire thing. Good? That makes sense? All right. Next one is zinc phosphate. So Zn, and phosphate is PO4. Again, it ends in 8. So you should be able to find that on the back side of your periodic table. 8s and ites are on the back side. So zinc has a +2 charge. This has what charge? Talk to me. -3. Good. All right. So I need to find the least common multiple between 2 and 3. What's the least common multiple? 6. So that means I need to get this side up to a +6 and this side up to a -6. So how many of these do I need to be at a +6? 3. And how many of these do I need to be at a -6? 2. But it has to apply to the whole thing. So give it a hug. Put it in parentheses. And there's your formula for that guy. All right, next one is copper 2 carbonate. So Cu, they told us 2 for the oxidation number, so we don't have to look it up. And then carbonate is on the back side of your periodic table. That is a -2. Am I at 0 charge right now? Yeah, then we're done. You don't have to do anything else to that guy. You're completely done with them. All right, zinc selenide. So, or nickel, I'm sorry, nickel 2. This is a +2. They told us in parentheses that it was a 2. All right, selenide, if it ends in ide and it's not cyanide or hydroxide, then it comes from periodic table. So this right here is your selenide. So that's Se. It's in that column, so that's going to be a -2. Where's my charge at now? 0, so we're done. You don't have to do any more. Manganese. Now this one's hard for some people because manganese and magnesium are not the same thing. Manganese is Mn, magnesium is Mg. So be careful with that one. It's easily confused. This is IV instead of VI. So IV is 4. And this is carbonate, so that's CO3. That's a -2. What's the least common multiple between 4 and 2? 4. Okay, so this one's already at 4. That means that I need to get this up to a -4. So how many of these do I need? 2. And what do I got to do? Yeah, it's got to be around the whole thing. All right, lead 4 nitride. This is NO3 for my nitrate. No, it said nitride, though. I just about messed that up, y'all. Sorry. This is nitride. So nitride means that it's coming off the periodic table. So that's going to be right here. This is my nitrogen, so it's going to have a -3 charge. What's the least common multiple between 3 and 4? 12. So I need to get this up to a 12, and I need to get this up to a 12, and that's how I'm going to do it. (10)2, so SN is a +2, and hydroxide. Now this is one of the 2 ides that are on the back side. You have cyanide and you have hydroxide. The rest of the ides come from here. So it's not cyanide or hydroxide, it's coming from this part of the periodic table. All right, so hydroxide is OH, it's a -1, so I need 2 of those to balance this out. All right, the next one is lithium, and then arsenide. Again, if it's not cyanide or hydroxide, it's got to come from here. So that's going to be this arsenic right here, right there. And that is a -3. This is a +1. So how many lithium do I need? 3. And now I've got it balanced out to 0. What is not making sense with these? What can I talk to you about? What are you confused about? Anything on any of these? I need to kind of know so that I know what to do with you. Help you out any way I can. So you're happy with these? If I gave you a quiz, you'd pass it right now? Then tell me what I need to do. What are you confused about? What don't you know where it's coming from or how I'm doing this or that or the other? Talk to me. What can I do for you? All right. The next one is covalent. So when we look at the covalents, we don't need to pay any attention to charge. There's no attention that needs to get paid to charge at all, which is kind of cool. It makes it a lot easier to deal with. Oh, that's still this page, isn't it? I moved that down here. I'm trying to find my stuff here. Now I got it. All right. If you look at one of these problems and you see in the second word that it starts with one of these number prefixes, then you know automatically that this is going to be covalent rules. Okay, So this has those number prefixes in it. If that happens, you're running by covalent rules. Okay? And all you have to do is these tell you what your subscripts are. So antimony, what is antimony? SB? Yeah. Antimony is SB. And this is bromine. And then I just have to write down the number prefix, which is 3. Hexaboron, hexa means 6. Mono means 1. And silicide would be silicon. So Si, and I don't write the 1 down. Chlorine and dioxide, this is oxygen. And I've got 2 of them because I had the prefix for 2 here. The next one is iodine. This is pentafluoride. This is fluorine. And then I've got 5 because penta means 5. And then phosphorus and iodine. And I have 3 of those because tri means 3. Any questions on any of those? Where I got the subscripts from? They're so much easier than the previous ones, I think. As long as you know your prefixes, you're good. All right, next one. Diboron. So boron, I've got 2 of those. Di means 2. And then tetrabromide, I've got bromine, and tetra means 4. Carbon, tetrachloride. Silicon, dioxide. Di means 2. See if you can do the last 2 on your own. All right, sulfur, octa means 8. This is acetate, that is AT. And hexa means 6. And then phosphorus is 4, and selenide is Se, and I've got 3 of those. You okay on those? Are they making sense? Yeah, I think the covalent ones are the easiest ones. So if it starts with a metal, ionic automatically. If it has one of these prefixes for numbers in the second word, and I say the second word because the first word doesn't always have one. If there's only one of those things, it doesn't have it. So that's why I say look at the second word and see if it's got it, because the second word will always have a prefix. All right, now we're looking at acids, okay? So with acids, you've got a couple different things going on. First of all, if it starts with hydro for the prefix, there is no oxygen in it. No oxygen if it starts with hydro. Hydro, there is no O, there's no oxygen in there. If it doesn't begin with hydro, so if it no hydro, it's going to have a polyatomic with oxygen. All acids start with H, with hydrogen. In their formula. For these polyatomics, if it ends in OUS for the acid, then the prefix, or no, not the prefix, I'm sorry, the suffix, the polyatomic, let's do it that way. The polyatomic will end in -ite. If the acid ends in ic and it doesn't have hydro in the beginning, then it's going to be 8 for the ending. Okay, so let's look at some examples of those. Well, I guess up here is probably easier to write it down. The first one is nitrous acid. So Nitrous acid. So it's pretty obvious that it's an acid because it has acid in the name. So that's how you know that you're going by those rules. Now, did it begin with hydro? No. So if it doesn't begin with hydro, then you know it's going to have one of those polyatomic ions in it. So what I tell my kiddos to do, and you're my kiddos now, is take this, wipe it out, and write ITE in there. And what you're going to do is you're going to go over to your polyatomic ion sheet, and you're going to find nitrite. Well, there's a little problem with that. And the problem is that all that's on there is nitrate, which is NO3 with a -1 charge. You need nitrite. What does it say to do to get to the ite ending? Look up in the parenthesis, the italic print at the top of your periodic table or the polyatomic ion sheet. What does it say to do for the ites? It says one ite is one less oxygen, right? You see where I'm talking about? On your polyatomic ion sheet right here. You see where it says that? Okay. Right here. Ite means one less oxygen. So nitrite is NO2 with a -1 charge. So then this is an acid. What did I say up here that all acids start with? Hydrogen. So I'm going to start with the hydrogen here. Then I'm going to write my nitrite next to it. So NO2. And then this is a +1. This is a -1. Do my charges balance at this point? If that is the case, you're done. It's written out then. All right. What? Anything there not make sense to you? Where I got what I got, how I got it? I need you talking to me. All right. The next one is Iotic acid. So this is Iotic acid. All right. Iotic, is there a hydro in the beginning? No. So we know it's going to have a polyatomic ion. So we've got to look at that. Ic came from what form? It came from eight. So it's kind of like conjugating verbs in foreign languages. Okay. This is os, and this became ite. This is ic, and it became 8. So I'm going to erase this, and then I'm going to look on the back side of my periodic table and find iodate. Can you find iodate on there? So iodate is IO3. It has a -1 charge. Hydrogen then is going to go in front of it because it's an acid. It has a +1. So at this point, we've got that charge balanced, and we're good to go. See if you can figure out the next one. There's no hydro, so it's going to have a polyatomic ion on it. It ends in OUS, so it's going to come from the ite form. See if you can figure out what this is. Arsenous acid. See if you can figure that out. It's going to have a polyatomic ion. It doesn't start with hydro. Where do we find our polyatomic ions? Right here. Polyatomic ions. They're on the back side of your periodic table. Arsenous. Okay. So OUS came from ite. So get rid of the OUS and write ite in there. See if you can find arsenite on here. Or something close. Okay. So that's 8. So how will we get to ite? Well, we got to do. Yep. So it's going to be AsO3. Good. Now what goes in front of AsO3? How did I get AsO3? Well, I saw that I need to get my ite form. I saw that arsenate was AsO4, the -3 charge. So arsenite has to be AsO3. All of these start with hydrogen. This is a +1, so I need to have 3 of these to balance out that -3 charge. All right, the next one is hydrophosphoric acid. So this one's a little special because it starts with hydro. When you start with hydro, that means you don't have any oxygen in there at all. So all you have to do is find the element that lines up with this. So what element would that be? Phosphorus. So this is P. And if you go back and look in your chart here, remember I had you mark down what that was? That's going to be a -3. So that's a -3. This is a +1. So that means I'm going to have 3 of these for every one of these to get my charge to balance. Bromic. See what you can do with bromic. Remember, this doesn't start with hydro. It's going to have a polyatomic. See if you can figure that guy out. Polyatomics are on the back side of your periodic table. Okay, so this is Bromic. Remember when I was talking a few minutes ago, the ic is going to change to 8. So change the ic to an 8. Okay, so now we're going to find bromate. See bromate here? Okay, so that is what you're going to write down next to your hydrogen. Okay. And now you check your charges. This is a -1. Hydrogen is always a +1. So they're balanced out. You're done. Okay. Now carbonate, it changes to what? Yep, so change that to 8 and then find carbonate. Now Now that's a -2. So how many of these are you going to need to balance that out? This is a +1. This one. Well, +1 minus 2 will give us a -1. So how many of these would I need? 2 of them. Yep. So put a little 2 down there between the H and C. Good job. Okay. So for bromic acid, it's an acid, so it starts with H. Bromic would have come from 8 form. So this is going to be BrO3, and it carried a -1 charge. And that was a +1, so they balance out. So then carbonic acid. Acids, of course, start with H. The ick would have come from the 8 form. So you find carbonate. This is a -2. This is a +1. So I need 2 of these for every one of these. Now the next one's a little harder. The hypochlorous. Let's talk about that one real quick. You might struggle a little bit with that one. Now here's what a lot of people do with that guy. They see hypo and they think hydro. So then they screw the whole thing up. So be very careful with that. Hydro will always end in ick. So hydro, you're always going to end in ick here. So when you have a hypo, it's going to end in OUS. So be careful with those. This is chlorous then. Okay. Hypo ends in OUS. So you're going to change that OUS to ITE. Remember we do that? We told you about that up here. So we've got to figure out what form that is. Well, I see in my chart that ClO4. Oops, it's getting away from me. Yeah, ClO3. I was getting it wrong. ClO3 is chlorate. So chlorite is going to be ClO2, and hypo, which is what this is, chlorite, is ClO. These are all -1 charges. So I put my hydrogen out front. I put my ClO out back. This is a +1. This is a -1. And I've got that one written down. This is permanganic acid. Ick changed from what? 8. So find permanganate. Figure out what permanganate is. Everybody's funny to me, but I'm sorry. It's a southern thing. My husband yells at me. People up here don't want to be called honey. I'm like, well, I'm sorry. You took me out of the South, and here I am, and it's just part of who I am. So take the girl out of the South, but you can't take the South out of the girl. Yep, that's a -1. So yeah, that's fine. Yeah. So phosphoric came from what? Take the ick away and make it what? So we find phosphate on here. And balance your charges. All right, so this guy, you should have gotten HMNO4. Okay, and then the next one is phosphoric. And the last one is sulfurous. So let me know if you didn't get those. Don't just copy my stuff down. If you don't know how to do it, call me over. Good job. Yeah, you did that one good. Yeah. Okay. Well, OUS, change that to ITE. And then figure out what sulfide is. You doing okay? All right. Is this making more sense now than it did before you came in here today? Okay. I know he taught at you a couple things, but I don't think it was like everything you needed. So I'm hoping that today has helped clear some stuff up. Don't feel bad. Some of my kids are in the same boat. Like I taught them, they're just like, I don't know what she's doing. I'm not speaking ill of him, I'm just saying. Okay, so you see sulfate on here, honey? You find that on here, right here? Okay. Right, so how do we make it ITE? Now let's read up here where ITE is. The ending ITE is for one less oxygen, so that would be what? One less is what? The 4. The charge never changes. The charge stays the same. Yep. And it has a -2 charge, so we need 2 of these. All right? Make sense? Yep. The charge doesn't change, it's just the amount of oxygen. So they talk about that, and you'll be able to use this on any test or quiz, right? That tells you one less oxygen. So it says oxygen there, not charge. So just keep that in mind. I'm not talking down to you. I just want you to see, because this is a tool you can use during a test or quiz. And so if you know how to use it, then you're golden, you know. All right, y'all. Oh, sorry. So your homework tonight is in that packet that I handed out to you the other day, in case you got quarantined. I'm going to borrow Nick's here for just a second. You've got 1 page of these formulas, all right? On the front line here, and then you got some naming too. I'm really, if you only have time to do one side of this or the other, okay? This is the side I want you to concentrate on. I need you to be able to write formulas for me. Over here, you're going to identify it as ionic, covalent, or acid. And then over here, you're going to write the formula. Okay? So why don't you do this column for me tonight? And why don't, on here, do the back side of this. So do the back side of this and that second column in your homework packet. Does that work for you? Because I'd rather you be solid on the naming or on the formula writing than on the naming. Okay? So do this and the second column in your packet. Good? And a lot of this is just going to be practice. You got to practice it, practice it, practice it, practice it. It's never going to come if you don't put the practice in.
You want this?
Yeah, thank you.
Are you already done?
Nick, are you standing on just the white tiles?
Yeah.
I don't think so. Get out of here. Out.